Pick up an iPhone, swipe your thumb across the glass, and it glides. But pick up a high-end Android with twice the RAM, and occasionally you might notice a microscopic stutter, a tiny visual hiccup right in the middle of a scroll. This timeline chart shows how a phone renders images. To maintain a fluid 60 frame per second illusion, an operating system must draw a new frame every 16.6 milliseconds. If an app takes exactly 17 milliseconds to process the next image, it misses its window. The screen is forced to hold the old frame for twice as long. Engineers called this visual break Jank. In the early days of smartphones, mobile operating systems managed resources exactly like desktop computers. The system processed the user interface with the exact same priority as a background process downloading a file or checking a server for emails. Apple realized that standard desktop rules would inevitably cause missed deadlines when dealing with direct touch. To guarantee they could hit that strict 16 millisecond window, they had to rewrite how the operating system distributed its processing power. We can trace this priority by looking at the exact sequence of events that triggers the microsecond your finger makes contact with the glass. Think of a standard OS like a kitchen. Tasks come in, downloads, texts, swipes, and the processor handles them sequentially. iOS throws that cue out. The moment a touch registers, it receives absolute priority. It bypasses the line entirely, forcing background tasks to instantly freeze. Halting background processes is a risky way to run a computer, but it ensures the main processor is completely unobstructed. It can dedicate all its calculation power to preparing that next frame before the 16 millisecond window closes. The entire device literally drops everything else it is doing to focus on your input. That hardware-level devotion is why the screen feels like a physical extension of your hand. Giving the processor dedicated time is only half the solution. The phone still has to physically draw the moving pixels onto the screen fast enough to keep pace with your hand. When you scroll, the application you are using isn't actually calculating the pixel colors. Instead, it generates a lightweight set of instructions, a blueprint, and hands it off to an entirely separate system called the render server. By isolating the visual drawing onto dedicated rendering hardware, the animation continues flawlessly even if the main app hangs up trying to load a photo or fetch a database query. But scrolling a modern social media timeline presents a major physical hurdle. If the render server tried to hold thousands of tweets, high-resolution photos, and videos in memory all at once, it would instantly overload the phone's RAM and crash. To solve this, Apple utilizes a memory management technique called cell reuse. As a post scrolls up and exits the top edge of your screen, the device erases the heavy data inside that specific cell, drops it behind the screen, and instantly recycles the empty shell at the bottom to catch the newest piece of data. It operates like a treadmill. The isolated render thread manages this seamless loop, ensuring perfectly fluid motion while never using more active memory than it takes to display a single screen's worth of content. Over the last decade, competing mobile platforms eventually engineered their way out of the jank problem. Modern Android manufacturers largely achieved competitive smoothness by throwing massive hardware upgrades at the bottleneck. They paired 120 Hz displays with 12 to 16 gigabytes of RAM to force a fluid experience through sheer processing power. Apple didn't need to overcompensate with raw specifications because their fluidity was built into the foundational architecture of the operating system from day one. Because iOS relies on strict resource prioritization and highly efficient recycling loops, an iPhone consistently hits the exact same benchmark of smooth performance while requiring roughly half the RAM of a comparable Android device. That gliding tactile feeling on iOS is the direct result of strict engineering constraints, forcing the entire machine to bow to human input. But this architecture creates a massive systemic risk. If the operating system constantly freezes background tasks every time you touch the screen, how does it clear out background memory without eventually buckling under the backlog? To survive this self-imposed bottleneck, Apple had to invent a hidden manager called Automatic Reference Counting, or ARC. How ARC safely disposes of heavy data right under your fingertips without crashing the device is a story for the next video.